Today we are looking at negative and zero exponents, and the goal for today is by the end of the lesson, we can simplify expressions with negative and zero exponents. Let's start by looking at negative exponents. We'll consider the expression 4 to the fourth divided by 4 to the sixth. Now remember when we divided exponents, what we did? Well, we expanded the format. So our 4 to the fourth power is laid out with the 4 fours up there, and the 4 to the sixth laid out with the 4 fours down there. What we did from here, once we expanded, is we canceled out what we could. So 4 fours up top and 4 fours down below. Now we cancel up top. It doesn't just everything just doesn't go away. We have a 1 still there. So it's like we're doing 1, number 1, there we go, pretty badly written, times all those 4s. So we're left with 4 over 4 times 4, or 1 over 4 squared. So what we can say is that for the negative second power, okay, which is what we left with here, we're left with 1, and 4 minus 6 is 2. So 4 the negative second equals 1 over 4 squared, excuse me. So the general rule we can say about this would look like this. If we have a number, we'll call it m, raised to the negative nth power, it equals 1, always 1 on top, over that same base to the positive n power. Right? So for the negative second, put a 1 on top always. That same 4 goes on the bottom. And then negative 2 becomes positive 2. That's the rule. Everything listed above is the reason why we can do it. So, for example, sorry for that delay, we'll do 5 to the 5th divided by 5 to the 8th. So we can lay it out. We have 5 times 5 times 5 times 5 times 5, which you guys can tell a little bit tedious to write. Then we have 8 fives down here. One second. There we go. Okay, so what we do now is we can cancel out what we have in common. So we have 5 fives on top. We can cancel out the 5 fives on the bottom. Leaves us with 1 over 3 fives, which we can simplify down to 1 over 5 to the third power. So now we're going to try some variables and constants. We're going to rewrite this problem using only positive exponents. So I like to set them up as more vertical. So we can say 20r to the negative 5th over 4r to the negative 3rd. Think of each term individually. So this 20 divided by 4 gives us 5. And r to the negative 5th divided by r to the negative 3rd, we know to subtract. So that's going to leave us with 5r to the negative second power. And we want to have positive exponents. So what's going to happen? That 5 stays the same, and that r to the negative second, we know becomes 1 over r squared. We combine that, it gives a final of 5 over r squared. If that was confusing at all, you can just go back, rewind, and kind of look at it piece by piece, because that's kind of a lot of concepts fitted into one problem. So now we're going to check on zero exponents. And the best way that I've ever heard this explained is think of a pattern. Okay, we'll use 3s. So fill in this table on your note sheet as we go through. So 3 to the 4th power is 81. We work backwards. 3 to the 3rd is 27. 3 squared is 9. 3 to the 1st is 3. And then let's look at what's going on here with our pattern. Okay, every time we drop an exponent, we're dividing by 3. So we're going to do that again right here. And we'll get 3 divided by 3 gives us 1. Now 3 to the negative first power, we know from the previous slides that becomes 1 over 3 to the first, which is 1/3. And 3 to the negative second becomes 1 over 3 squared, which is 1 to the 9th. And again, if you test it out, we're dividing by 3 each time. So we're dividing by 3. That's our rule there. Let's try it again with our 2's. Okay, 2 is an easy number. We got 2 to the 4th is 16. 2 cubed is 8. 2 squared is 4. 2 to the first power is 2. Notice again, we're dividing by 2 or by that base every time. So divide by 2 again, and we get 1 right there. We know this one becomes 1 over 2 to the first, which is 1/2. This becomes 1 over 2 squared, which is 1/4. And again, divided by 2 each time. So look at both tables. When the exponent is 0, each time we end up with a number 1 as our answer. You cannot make 1s very well here. So we can say the simplified version of any number that is raised to the 0 power is 1. Kind of a long way of getting to this very basic, easy rule. This concludes your lesson on negative and 0 exponents.